All right. Gabi, take it away.
Thanks, Joel. Um, okay, so I will present about Sankey diagrams. I hope I'm saying this right. I'm still learning about it, so I will show you a little bit what I know so far. So first of all, what is a Sankey diagram? Sankey diagrams show the flow of quantities from one set of categories to another. The width of each arrow is proportional to the size of the flow and is great for tracking how things move, split or merge. So if you've never seen before, this is what it looks like. I will explain a little bit later. But basically, this is like a flow chart, but with weight. And where are they used? They can be used for a lot of different things. So this is just examples like energy systems to show input and output and losses. Also for healthcare, patient pathways, disease stages can be used for finance and economics, for budget allocation, supply chains, for data analysis, like survey responses, user behavior, transitions, and how to read them. So we have nodes, which are the categories or stages. There is like the boxes, that is the source and the target for the visual part. The flows, there are the movements between the nodes, so the links that looks like arrows. The width is like the value or amount is like the quantity. So the bigger it is, the thicker it is, the bigger is the value. Um, and the colors, they may represent different groups or attributes, but it's not like mandatory to have different colors. It's just an easier way to show different things. And why use Sankey diagrams? It's an intuitive way to communicate complex data. It can highlight imbalances, bottlenecks, and key flows, and also helps guide decisions planning and resource allocation. So here I have a couple examples to show you um, how can be used. And so this one is for vaccination in children. And here we have different timestamps. In each one is like the age of the child, which is 2 months, 4 months, 6 months, and 12 to 15 months. And in each one of these gaps, we have different recommended vaccines and the number for each age. So in 2 months, we have 5 vaccines that the child can take it. And the visual representation in the diagram is each color represents a number of the vaccines. So for this first one, we have 5 different vaccines, and each color represents one of them. So we have 83% of the child, they take the 5 different vaccines, 4, and 3, 2, and 1. And we can see this gray part is like the flow that goes to the other timestamp, which is 4 months. And here also we have 5 vaccines, different vaccines that the child can take. So we can see that 73% had all the 5 different vaccines. And this is, we have um, the first month had the 5 vaccines, also have the 5 vaccines at 4 months, but we also can see that we have smaller flows coming from the other gaps, from the other number of vaccines. So this is basically how it works. We have a source and a target, and we can see how it comes from the first one to the second one to the third and the fourth in this case. So it's interesting. So we can visualize like this last one, we have 3%. um, of the children had all the six vaccines, and it comes from all the other gaps before, all the other ages before. So we have kids here that had all the vaccines from the other times, other ages, but also they only had the six vaccines in this one. This is another example. This is water research. It's completely different from the other. Here we have a different type of flow. This is a representation of the water accretion during winter. So each one of these arrows are different flows, and the numbers show liters per second. So we can see that it's growing until the last one. So it's just a representation of different types of fonts from the water. And this one, it's for patients with carcinoma. And here we have different types um, of representations of the same type of diagram. So each color here represents a different type of treatment, and each diagram has a different type of way of showing. So here we have the total number of patients, and we have chords for different years. Here we have glomerular filtration rate for the different types of treatment. And here we have age groups. So based on this, I'm going to show you the manual for the package I used on R. I know that there is a lot of different ways to make Sankey diagrams on R. And this is the easiest one I found because my first interaction with this was Timothy needed help with one figure for a Sankey diagram, and then he already had the code. I he just needed help with the more static part. So he sent me his code, and it was really hard for me to understand because I'm still a beginner on coding in R. So I thought it was really interesting. It was the first time I saw a Sankey diagram. So I thought about learning, and I found this package called Network V3. Um, and here I read it, the how to use it. So these are all the arguments that we can use and how to put this on the code, how to use it. And based on this, I created the code for the data set that I have. So first of all, these are the packages that I use it. And this data set is a birth registry from 2023 in Brazil. Um, it's for the whole country. So the first thing that I did was the glimpse so I could see all the variables that I had on the data set and decide which were the variables that I wanted to use. And I thought it would be interesting to try to relate race of the mother with the number of doctor appointments for prenatal care and the baby weight. So the first thing that I did was a mutate for the variables because it's in Portuguese. But this first one is for the race of the mother, and the second one is for the number of the doctor appointments, and the third one is for the baby weight. which is in grams. So this is the consider low, and this is the normal or high. So after I did the mutate, um, I was going to build the links, which are the flows. So I needed to split into two steps, and then merge them. So the first link that I did was the race as the source and the doctor appointment as the target. And the second link was the doctor appointments to the baby weight. And then I merged both links and should and I use the bind rows because for this type of analysis it needs to be lines and not columns. So I use the bind rows to merge them. And then I came to the nodes, which are the boxes with the source and the targets. And for this, I used to create a vector of the nodes and a data frame. And for this package, it requires the name to be zero-based index. So I needed to put this um, -1 because the codes are in numbers. You can see here it's starting on 1. So it needed to be zero coded. So I needed to put this to work. And here I was trying to match the source and the target so the flow would go correctly from the first one to the second and to the third. And after this, we have the nodes, we have the targets, we have the flows. So we just need to generate the diagram. And for this, I just put here the links and the nodes with the names that I gave it. And the different thing that is not made is just an argument, is more aesthetic. So I have the font family, the font size, and the node width. And here we have the Sankey diagram. And it's interesting about this package is it's like a Java that JavaScript. So you can make this, you can change whatever you want to look. I don't know, depending on your aim, you can change it, the aesthetic. So um basically you can make it how you want it to look. So here I use like the Montserrat font family, but we can change that for anything that you want, like the everyone favorite. And you have a different type of font here. And depending on what you want, you can make it work. So I think it's funny because you can do whatever you want. But I will keep it the more serious. Um, Also, you can change pretty much anything. You can change the width here. You can make it thinner. And it really goes to the what is your aim. And you can also change the color of the nodes. And then you have a different type of colors. You can choose whatever you want. And you can also change the color of the flows. So it won't be only gray. And for that, we will need to create group to use this a link group that is the color for the links, the flows. So here I'm using the color of the source. And then we can see that the flow, it's also the color of the node of the source. Yeah, and you can export it, and that's it.
Can you show us, Gabi, a little bit of the interpretation of the graph? Just an
Yes,
example using the race as you build. How would you go about interpreting the relations?
yes. Um, so here we have the different races that we used, which was Black, White, Indigenous, and Asian. And here's the number of appointments, and here is the normal height, babe weight, and the babe weight. So for this, we had that most of um the patients were Black and had seven appointments or less. And we can see when we put up this on the node, they shows the number. So here we have more than 1.5 million people that were Black, and here we have more almost 2 million people that have seven or more appointments. And the interesting thing about this is that with these colors, we can see how it goes to different places. So we have like people that had seven appointments, but also four to six, one to three, and 0 appointments. And for the outcome is the same thing. We can that show that the more you have, the more appointments you have, it's better for the outcome to a normal or high weight for
Mm,
the baby.
I see. And the numbers are amounts, right? They're not proportions in this case.
Oh, it's just the value.
Okay, the raw value. Nice. Cool.
Yeah.
Thanks. Any more questions for Gabi? Uh, or any projects that you guys you think that this type of analysis or a plot would be useful?
Um, it has been difficult for me to understand this diagram, to be honest. Um, can you maybe go through the interpretation one more time? Sorry,
Yes.
doesn't make sense.
Yeah. So I use three different variables that I wanted to relate, which was the race of the mother, the number of doctor appointments that they had during prenatal care, and how that affected the weight of the baby. So the first column with these boxes are the races. So I have the Black, White, Indigenous, and Asian. And here I have the number of appointments with 0, 1 to 3, 4 to 6, and 7 or more. And I have the normal or high babe weight and the low. And this is important because usually kids that are born with low weight, they tend to have more issues, more problems. So the size of each one of these arrows are represents the number of the people, the value that we had in each one of these columns. So here, as on black, for example, we have that the biggest part is going to the 7 or more appointments, which means that the most part of the black moms, they had 7 or more appointments.
Useful
But we
and
also have, okay, but we also have other smaller flows going to the different other categories on the variable of the number of appointments. So each one of these flows shows a different number in the second column, which means that we also have a smaller proportion of Black mothers that had 46 appointments. And here's the number 2009, 5,000. And the same thing happened to 1, 2, 3, and 0 appointments. And for the other part of the diagram is just the same. This column is the number of appointments and how they impacting the weight of the child. So we have the 7 appointments or more. There was almost 2 million mothers had. And we have the biggest part of this flow going to the normal high weight. But we also have this little part that goes to the low. They even go into more doctor's appointment. It doesn't change the fact that the kid was born with lower weight. Does that make sense?
So, yeah, good job, Gabby. I think if I can add like a little more to help us understand the kind of utility of this kind of diagram, as Gabby said, you can see at a glance, and when she does it with this way that's the Java, like it's interactive, which is nice. Obviously, in our publications, we might not be able to do that, but we could add some of those details in the figure, perhaps. But it tells us a few things. One, at a glance, we can see the relative proportions in each group associated with the next variable, which she walked through just nicely there. But also we can see the, the aggregate information as well. So each closed rectangle is telling us for the whole population, you can see that the population is majority Black. You can see that the population is majority getting the 7+ appointments. You can see the vast majority is getting the normal or high birth weight. So those are nice like summary characteristics of the whole sample in the closed rectangles, which is a nice way to represent the data that we might otherwise just put in a table, aside from the flows from one variable to another. So that's nice.
But there are no statistical tests in this, it's just a descriptive table. Oh, okay.
Yeah, I suppose you probably could add like chi-square values for the relation, the binomial, the bivariate relationships, but that's not presented, no. So that's a fair point. You can't conclude anything from just this figure the way that it is, but given the sample size, I'm quite sure there are significant differences.
Yeah, from what you have, from this explanation, it would make sense that the low birth weight actually have more visits, right? Because they might be much sicker. I would imagine. Like premature.
So Edwin, this is a visualization. Okay, it's not an analysis, it's not an estimation, it's not an inferential statistics, it's a visualization. I'm assuming that as you are representing this in your paper, this would come in company of a table with appropriate statistics, or any kind of inference you want to make. I might even argue that in given situations, this would be used in a paper. It's great for a presentation. It's great for a summary of the data. Now, the way that I look at this graph and what I see is two bivariable associations. So I'm looking at the association of race and number of consultations. And then I'm looking at the association of number of consultations and whatever normal and high and low are, because I came in a little late, so I don't recall what those are. So blood pressure, let's say.
The birth weight. Yeah.
Birth weight, yes. Okay, so that's what it's looking. It's just showing the two associations, and it's a way to represent how the associations happen. But when you stack them into this linear representation, you can make the hierarchical relationship also apparent. So I can understand that the majority of Black people in the sample, as much as white, are under the normal appointment rate and under the normal birth weight or whatever. But it does show the hierarchy of the associations. So assuming you have a good theoretical foundation to read the associations the way they are being represented, then this would be an interesting interpretation. Now, nothing stops you from adding the odds ratio of the relationship here in each of the buckets if you want to bring in more evidence to the graph. And the graph is illustrating that relationship you've just calculated the odds ratio for in a more unbiased way. But it allows you to summarize that, but it's nothing more than bivariable associations looked at from a hierarchical perspective, right? We would hypothesize that race predicts number of consultations that then predicts birth weight. Okay. Now, if these variables were variables that had a longitudinal relationship, it would make a lot more sense. It would be a lot easier to read. Because if you had, for instance, groups belonging into one class in the first column, and then groups belonging into the same classes in the second column, but separated over time, then you could see transition. That would be very interesting as well.
Do people do that with these Sankey diagrams, Gabby? You understand what Joel's suggesting?
Yes, yes. That would be the same as the example I showed about vaccines because it's the same population. It just changed the time stamp.
Can you show us that again?
Yes.
Hmm. So I don't know if this one is showing exactly what he's suggesting. He's suggesting like that we would have an indication, like if you look at the section between 4 months and 6 months, you can't tell which part of the 73% to the 62% came from the original 2 months segments.
Yeah, I get it.
Yeah.
Go on.
I would just guess you could add a layer of like a texture or some other element to display that. Wouldn't you think that would be possible?
Yeah, because you can add like the number because usually here's percentage, but you also have like the value and you can change that. But you can also add here, for example, like which is this with this and how this transfers to this one. And you can add like the number or something like this.
Yeah, this is a very interesting representation of how things change over time. And then in this representation, you can clearly see which groups are transitioning to what groups over time, which I think is a very interesting representation. Cool. Okay, any other questions to Gabi? Okay. Okay, well, Gabi, thank you very much. This was great presentation. Appreciate it.